All thermometers utilize some physical property of materials that changes predictably with temperature. And any such property that changes with temperature is called a thermometric property. Some thermometric properties include dimensional changes, such as volume or length. Examples of this are the common mercury in bulb thermometer or the bimetallic strip that will be discussed in later sections that is commonly used in thermostats. One type of thermometer takes advantage of how the temperature of a gas at constant volume changes with pressure. There are also thermometers that are based on electrical resistance or on thermoelectric properties. The principle of operation of a fluid and glass thermometer, as we have already seen, is based on the dependence of fluid volume on temperature. Most fluids expand when heated, and all we need to do is calibrate this expansion with regard to temperature by finding positions of various known temperatures, like the ice and steam points of water. A constant volume gas thermometer consists of a gas-filled bulb to which a pressure gauge is attached. The bulb, usually filled with hydrogen or helium at low density, is placed in thermal contact with a substance whose temperature is being measured. The gauge mechanism is called a U-tube manometer. The volume of the gas is held constant by raising or lowering the right column of fluid, which is usually mercury, so that the fluid level in the left column is always at the reference level. The temperature of the gas, and therefore the substance in which it is in thermal contact, depends on the difference in the heights of the two mercury columns indicated by H in the diagram. The larger the difference, H, the higher the temperature. The thermocouple is a thermometer used extensively in scientific laboratories. It consists of thin wires of different metals welded together at the ends to form two junctions. Often the metals are copper and constantan, a copper-nickel alloy. One of the junctions, called the hot junction, is placed in thermal contact with the object whose temperature is being measured. The other junction, termed the reference junction, is kept at a known constant temperature, usually in an ice-water mixture at 0 degrees Celsius. The thermocouple generates a voltage that depends on the difference in temperatures between the two junctions. This voltage is a thermometric property and is measured by a voltmeter. With the aid of calibration tables, the temperature of the hot junction can be obtained from the voltage. Thermocouples are used to measure temperatures as high as 2300 degrees Celsius or as low as negative 270 degrees Celsius. In summary, all thermometers utilize some physical property of materials that changes predictably with temperature. Finally, a property that changes with temperature is called a thermometric property.